In Lecture 40, we played with logging sensor data to Nimbits, a cloud service dedicated to the task. Nimbits will collect the data from your sensors and plot them in a chart, or you can download them in a data dump and process them on your computer. What if you'd like to post your data for anyone to see on the internet? Well, just like people can post their holiday adventures on Facebook, gadgets can post their worldly observations on Twitter. In this lecture, I'll show you a very easy way to do just this. Twitter is a private messaging service owned and controlled by a corporation, Twitter Inc. It is one of the most popular microblogging services in the world, if not the most popular. To post a message on Twitter, you need an account and a Twitter client. Because Twitter has an interest in protecting its infrastructure and users from unauthorized use, it requires that any tweet is authorized. This makes the tweet legitimate. Twitter, like many other websites and services, uses an open-source authorization protocol called OAuth. This protocol allows a third-party application, like a tweeting Arduino board, to gain access to Twitter's application programming interface, or API. So it is quite possible for you to include code in your Arduino that implements OAuth as a client and use Twitter's API to tweet sensor data. But there is a situation here to consider. If Twitter decides to make changes to the way it authorizes tweets, you will have to update the code on the Arduino. If the Arduino is on your desk, that's no big deal. But if you have deployed an Arduino-based product and can no longer access it, then you have a problem. Although changes like this are very infrequent, they are possible, and because you have no control at all over Twitter's API changes, there is a small but existing possibility that this will be a problem one day. The alternative is to use an authorization proxy service. This is also my favorite solution to this problem. Your Arduino will send a tweet to the proxy with authorization credentials that the proxy supports, and from there, the proxy will relay the message to Twitter. As long as you have control over the proxy, you will be safe from changes to Twitter's API, because any changes you have to make are in a single proxy only. In the demo in this lecture, I will show you how to set up an open source proxy called Arduino Tweet, authorize this proxy for posting tweets to Twitter, and getting the Arduino to send tweets to the proxy. This architecture is depicted here graphically. In the first demo, I'll show you first how to get a token for publishing tweets to Twitter via the Arduino Tweet proxy. Then, we'll download the library from Arduino Tweet and install it in the Arduino IDE. And finally, we'll run the test sketch that comes. And finally, the third step is to try out the example sketch that Arduino Tweet application provides. So the method of getting the Arduino to tweet that I'm going to show you is made up of two parts. There is the Arduino Tweet proxy server component and the library. These two work together. We'll start with the server and the proxy. In this GitHub account, there's a repository called Arduino Tweet lib server. It's an open source repository. It contains the Python code that makes up the Arduino Tweet proxy server. There is a public instance for this, so you don't need to have your own server running, but you can. Earlier in the lecture, I mentioned that Twitter does not change its API, especially the authentication part of its API, very frequently. It's actually a very infrequent thing to happen. And in fact, it did happen. As I was recording this lecture sometime last night, I realized that GitHub had made a change that broke this code. It broke the code that the library is using to connect to the API, the Twitter API. So I had to go and make a few changes to this open source code, and eventually spawned my own instance on the Google App Engine. And here it is. So the URL to use this, which is free for everybody, is asps.twitter.appspot.com. Feel free to use that. So let's go ahead and go through the process. The first thing we need to do is to get a token, so we can use this token from our Arduino sketch to post to the proxy first, and then from the proxy to Twitter. So click on this link. It will take us to Twitter, where we'll authenticate ourselves and essentially give permission to the Arduino Tweet proxy to post on our behalf on this account. So I'm going to copy and paste my credentials. I have already created the Twitter account that I want my Arduino to use. And I will authorize the proxy. Now the token shown here, I need to copy this. I will store it because I'm going to use it in a minute. Next, it's time to get the library into the IDE. So there's a link here. It allows you to download the required library. This library is only going to work with my instance of the Arduino Twitter proxy. So I have downloaded it, and as always, you need to grab it. So here's a library. Make sure all the contents are in. So these two files are the important files. So copy it and put it in my Arduino IDE's libraries folder. It's already here, so I'm not going to continue with overriding this folder. Done with this step. Finally, let's grab the example sketch that is suggested by the proxy. I'm going to copy it. And paste it in a new Arduino sketch. Need to copy the token that I required earlier and set it in here. So that's how I initialize a Twitter object that the Twitter library provides me. I also need to fix the IP address for the Arduino. So I'll make it compatible with my network. 1 and 2, 111. Sorry, it's 168. 111, 177. That is fine. And everything else looks good. So let's upload it and see what happens. Okay, check the monitor. Connecting. Oops, failed. Now, why did it fail? I want to see why it failed, so I'm going to pass a reference to the serial object, so that way I'll be able to see what Twitter is sending back to the Arduino. Okay, it's because I have already sent this message in the past. So, yeah, one thing to remember with the Twitter service is that it does not allow duplicate messages. So if you try to send the same thing twice, identically, then Arduino, so the Twitter service is going to reject that message. So I'm going to make a small change. Arduino, hello world. I'll say hello world again. I'm Arduino. Okay. Done uploading, connecting, and we have success. So the message was sent. Let's go and double check and make sure that it did go onto the cyberspace. So check my account on Twitter. Yep, there you go. So hello world again, I'm Arduino. Now that we know that the Arduino can tweet via the proxy, let's customize the message that is posted. Let's make it so that it reports a value from one of the analog inputs. I would like the Arduino to tweet regularly, say once every hour. Well, that was fun, but not very useful, obviously. Just sending hello world again and again becomes kind of boring, even if Twitter would allow that to happen. So in this demo, in the second demo for this lecture, we'll do something more useful. We're going to get some readings out of this analog sensor. You can just replace the photoresistor with whatever analog sensor you want, and broadcast the values from the sensor for the whole of the internet to see in cyberspace using Twitter. So let's fire it up, make sure that it works, and then we'll go through the sketch and see what the sketch is doing. So uploading. Done uploading. Check the monitor. Oops. Okay, so I've got a very high value. I think it's just posting once every 1 hour. So I'm going to have to wait for 1 hour for this first post. So instead, I'm going to make that 10,000 so that we're going to have a post every 10 seconds. So try again. Done. Check now. In 10 seconds, there should be the first post. Connecting. Okay. So we sent a bunch of values to Twitter, and Twitter responded with OK, which is always a good thing. Let's have a look at what we actually sent to Twitter. So I'm going to refresh my account. And there you go. So we've got 2 posts so far, light intensity with integer value in here. So how did this happen? Let's have a look at the sketch. So just like in the first demo of the lecture, we are using the Twitter library, and I'm also using the pstring library that we saw in lecture 40. If I remember correctly, it's going to allow me to put together the string that I want to send to Twitter. I don't want to post every few milliseconds, so I want to keep a nice time separation between the posts. So I've got 10 seconds here, that's 10,000 milliseconds. A more reasonable amount of time to post might be an hour, depending on your application. I prefer 1 hour, so I'm going to change this to 1 hour a bit later. It's going to be 360,000 milliseconds. The networking components are the same as before. Here's my Twitter token, just like in the previous demo. Then I am preparing my pstring object. Just like we saw in lecture 40, I need an array of cars. Twitter messages are small, so 200 characters will be enough. And I'm going to be using the tweet pstring object to handle the string that eventually I will tweet. We do the setup in the setup function, and then in the loop, assuming that enough amount of time has elapsed, that is the posting interval that ensures that enough time has passed before a new post is sent out, then I initialize my pstring and take a reading from analog port 0. So I start to construct the message by putting a light intensity string first, and then that is followed by the value that I read from analog pin 0. Then I attempt to post the pstring, and if the response is good, then I proceed. I grab the response from Twitter, and with this symbol here, this is a pointer or a reference to a memory location where the serial object is receiving any text that I'm sending to it, so that I can display it to the monitor. If you don't want to see any responses from Twitter, then you just remove this and you don't pass a reference to the serial port. So if the status that I received from Twitter is 200, then everything is good. I can print that out and move on. Otherwise, I print out the failure status code. That's about it. You just update the last connection time with the current number of milliseconds since the Arduino started, and the loop continues all over again from the beginning. You can see that with a proxy managing the communication with Twitter, posting tweets with the Arduino could not be any simpler. With the code for both the Arduino library and the proxy being open source, you have peace of mind that your tweeting infrastructure can be built on your own hardware and be in your total control if you ever need to. As an exercise, make the necessary changes to the custom sketch from Demo 2 so that your Arduino tweets data from multiple sensors.